Okay, welcome to Solving for Variables. This should help you solve variables in this class. And if you get this, the rest of the math in this class is really easy for the rest of the year. So easy, we say it's easy peasy, lemon squeezy. Oh, I drew a lemon there. That looks pretty cool. Remember, physics is not math, but we use math as one of our tools to analyze uh, different objects of motion or how different physical things interact. That's what it's all about. So we do lots of three variable rearrangement, and most of the equations we deal with would be something like this, where maybe I have A is equal to an average velocity, and then B is, maybe A is let's see, B would be average velocity times time, and that would give me my change in position. Okay? Or I could have average velocity, change in position over time. Or I could have time is equal to change in position divided by the average velocity, right? And so these are the three main ones that you'll need to be able to do. And notice, like, we have this is our first real equation right here, right? Which is our average velocity equals change in x over t. So then on many of your assessments, I've asked you, well, I want you to solve for t. I want you to get t by itself. I want you to isolate t. You said, okay, well, I multiply t on both sides, the t's cancel out, and then I get this equation right here, where t is equal to change in x over average velocity. And then we also have this one. If I wanted to find the distance with the displacement, I have my change in x is equal to velocity, average velocity times time. Okay, so that's why we rearrange these, so that we can solve for different things depending on the information that we have. Oh, this is the question. So when you guys got this question, every time you do these, you should really look at what do I know? So I'm going to read this. A dog ran across a 20-meter field. Okay, so 20 meters, that's going to be my displacement. At a constant velocity, so the velocity is not changing, so there's no acceleration, so I should not use an acceleration equation. And 2 meters per second. Well, meters per second, that's a velocity. So I know the velocity is going to be equal to 2 meters per second. How much time did it take for the dog to cross the field? So what I don't know is time, and that's what I'm looking for. I'm looking for the time it took the dog to cross the field. So when I have this, I'm going to say, okay, what equation do I have for my NGSS equation sheet that has both change in x, average velocity, and time? Well, that's the equation that we've been using. Average velocity is equal to change in x divided by time. Okay, so my equation, done. Check that out. Look, that's what I mean when I say I want you to write your equations down. Then I'm going to show my working. Ooh, but before I can do that, I need to rearrange my equation, don't I? Because I'm solving for time. So I need to get time upstairs and by itself, or isolate time. So I'm going to multiply t on both sides. And when I have a t on top and a t on bottom, or a t in the numerator, a t in the denominator, they can cancel out. Because it's like it's like a 1. So now I have this equation, t times average velocity is equal to change in x. But I want t to get t by itself. So what do? Well, I divide change in v on both sides. And so now the change in v's cancel out on this side, and I have t is equal to change in x divided by average velocity. And that's my equation. Sorry. There we go. Awesome. Now I need to do my working, so I'm going to fill in the numbers. Well, now it's really easy. I just go 20 divided by 2 is equal to 10. And what are the units? Well, if I have meters per second here, meters here and meters per second here, the meters cancel out and the seconds go to the top. Or I just see that I'm looking for time. And if I keep everything in meters and seconds and meters per second, then everything's going to be in seconds at the end. So I've shown my work and I've shown my correct answer with units right there. Okay, so that's what we're looking for. Good. Let's keep going. So this is why it works. We can just switch these numbers around any way we want. And you can see that if I even put in numbers, they would still be correct, right? 10 times 2 is 20. 20 divided by 2 is 10. 2 is equal to 20 divided by 10. Hopefully that makes sense. So now you can go ahead and plug in your own. You make that chart in your notebook. You can do two if you want. Okay, so here again is how to solve for x. So I took off my deltas, right? Because usually we have a delta here, usually have a average velocity here, but just to make this as simple as possible, I decided just to take off those. But if you do have a triangle there, a delta or an average bar, that sticks with that variable the entire time. If the problem is a car going 30 meters per second for 10 seconds, how far has the car traveled? Then you need to use the equation from the equation sheet to solve for x. Here's how you rearrange the variables, or sometimes it's called isolate the variables to get x by itself. So I need to get x by itself. I'm going to multiply both sides by t, like I did here. As I said before, the t's cancel out. This t doesn't cancel out. What? Madden. That t doesn't cancel out. Careful. So then I get tv is equal to x. So now if you gave me a time and a velocity, I can give you the distance it's traveled just by multiplying those together. Notice how I don't use the multiplication sign anymore, as it's understood that tv means t times v. Okay, here's another one. Solve for t. Oh, should we just solve the problem? Yeah, let's do it. So a car going 30 meters per second for 10 seconds is going to be equal to 300 meters. So I've got my equation, I've got my working, and I've got my correct answer with units. Yay. All right, a car travels at 20 meters per second for 100 meters. How long did it take? Now I need to solve for time. So I'm using the equation from the equation sheet, which is this one. Then I'm going to multiply time on both sides to get time isolated. Then I've got this v over here, and I need to get t by itself. So then I'm going to divide both sides by v, and those cancel out. So I get t is equal to x over v. So now t is equal to x over v. There's my equation. My working is 100 meters divided by 20 meters per second. That's going to be equal to, what, 5? And what is my time? So I'm looking for how long, so that's 5 seconds. Now, when we get more complicated, it kind of does the same thing. Like all we're doing is dividing or multiplying variables across the equation to get certain things by itself. So let's try this one. It's a little bit more complicated. Let's say we have this equation, which is actually the force of gravity between two big objects, like mass of the sun and mass of the earth, and the distance between them squared. The big G is Newton's gravitational constant, which we'll get into second semester. But we can practice on rearranging. So I want to get big M by itself. Okay? Well, big M is right here. And I want to get it by itself. So first, I'm going to divide by G and little m. So if I divide by G and little m on both sides, the G and the little m get canceled out on the right side of the equation over here. And I'm left with F over GM is equal to D squared, right? So F over G little m is equal to big M over D squared. Now I need to get rid of this D squared here. I need to get rid of that and get it to the other side. So I'm going to multiply both sides by D squared. The D squares on the right side cancel out. And I am left with, D squared F over G little m is equal to big M. And I'll usually write this. You'll see me do this in class all the time. I flip it. So I have the isolated variable by itself, and then I rewrite it. Okay. Now, if you have mastered this, and this, and this, and that makes a lot of sense to you, go do some practice. Make sure you can do it. Now, once you can do it, we've got some cheat codes down here of how you can do it really, really, really fast without so much work. But again, make sure you learn the math version first, and then you can kind of use this visualization way of rearranging the variables that I use a lot when I'm solving physics problems. Okay, great. I hope that helps out, and I look forward to seeing your learning.